Hello viewers, welcome to Digital class. I am Rasmita Jena, lecturer in computer science. So in our last video, we have already discussed about how we can create the number of nodes in single linked list, and in today's class we will be discuss to traverse that list, or we will be display the data those are created in single linked list. And in today's class we will be discuss to traverse that list, or we will be display the data those are created in single linked list. So first we will know what is the structure of the node. So this is the structure of the node that we will be create by using a struct keyword. And in the node we know that every node has two parts. One is the data part or number part, and one is the next part or link part that link to the next node. So the structure contains one number part and one address part, that is struct node type pointer we must declare to hold the address of a struct node. Okay, that means this is the pointer variable of struct node type to hold the address of a node, and this is the structure we already defined at the time of creation of the single linked list. Okay, suppose we have two variables, that is struct node, two pointer variable, that is struct node start, and second one is a p. And initially these two variables, suppose they are contain null values. Okay, here the start variable used to hold the address of the starting node, and p is the another pointer variable which is also used to hold address of a node. Okay, let's see the function implementation of linked list. So before we must know about what is the structure of the link, or what are the data elements are present in the single linked list. At the time of creation we have created three nodes in the single linked list. The first node is created at 100 location and containing data 10, and the second node is created at 200 location which will be pointed by the first node and containing data 20, and we have another node in the single linked list, that is third node, which is created suppose at the 300 location, and this is also held by the address part of the second node, and the data part of the 300 contain 30, and we know that the last node of the single linked list contain null value at the address part. So this is the list which I have already created at the time of creation of single linked list. So in this class we will traverse this node by executing the display function, or by executing a traverse function. Okay, that is a user defined function. You can take any name. Okay, so when we traverse a single linked list, what is the function definition structure? In single linked list we will receiving the address of the start node, and we doesn't return any value to the calling part. So here you can see, here I am declaring a variable, a pointer variable, a struct node type pointer variable which contain null value. So initially the start pointer will contain null value. Okay, but when the list is created, then it will become 100. Okay, and similarly the another pointer p which is initialized as null value. Okay, so as we are not returning any node to the calling part, so the return type is void, and the function name is display. You can take any user defined function name, and we are receiving the starting node because we will start traversing the node from the beginning of the list. That we need the starting address of the node. Okay, or that is the first node address of the list. So here struct node start. That means from the calling part the function will call with argument the address of the start node, and it will receive by the another pointer, that is struct node type pointer, that is stat. So stat became null, and when we create the list, the start became 100, and when we call the display function, again the formal argument start variable will hold the address 100. Okay. So first we will display this node, and we have a pointer variable, struct node type pointer variable, that is p, and which is initialized as null. So initially we will be initialize p equals to start. Okay. It means when we call this function, the start will hold 100. Okay. And we initialize this 100 value with the variable, with the pointer variable p. Okay. That means the p became content 100. So next we will traverse the node. Okay. So first we will check the list contain any node or the list is still empty. That means if we not creating any node in the list, then the start contain null value. As we already created this list, so start became 100. Suppose let assume that the list doesn't contain any node. Then what will be the value of the start? The value of the start is null. So first we must check the list contain any node or not. So for that I can write if p equals to null. That means start contain null value, and that start value is assigned to p. So first we will be check p equals to null. If this condition is true, it means still the list is empty, doesn't contain any node. So we will print a message, that is printf list is empty. Okay. Then the ending curly braces of if. Okay. Suppose next let assume the list is created, and we also create that list. Suppose the list is created and the start value became 100. Okay. As the start value is 100, and when we call this display function, it will pass the argument, that is the value of the static node. So it will receive by the start pointer, and when we initialize p equals to start, that means this value is assigned to variable p. Okay. That means the p becomes content 100. Okay. So when we execute this statement, that is if p equals to null, then this condition is false. That means the list contain at least one node. Okay. Then come for the else part. In else part, we will execute a loop for traversing all the node in the list. So here I am taking a while loop. Okay. While I will check the condition p not equals to null. Okay. That is the condition p not equals to null. You can see p contain 100. So this condition is true. P not equals to null. This condition is true. As this condition is true, then we will display the number part or data part of the 100 node. Okay. So for that I can write printf %d, because we are creating the structure of the node which contain a integer data. That means the data part of the node will contain a integer value, as we are declaring int no. Okay. So printf %d will display the number part or data part of the 100 location node. So 100 location node, the data part or number part will contain 10. So we will display this. So for that I can write the statement, that is p arrow no. Okay. It means the 100 location number part contain data 10. Okay. Then we will increment the pointer. As we are executing a loop, we must go for the forward traversing. Okay. So for that I can write p equals to p next. Okay. So p equals to p next means next is the pointer which is hold the address of the next node. So p is 100, and when we write p equals equals to P nest. That means the P nest contain 200. So this 200 became stored in the variable, pointer variable P as 200. So P becomes 200. Okay. Then in the same process, we will execute the loop until this condition is true. So now P is 200 and we will check. 200 is not equals to null. The condition is again true. As this condition is true, then we will execute the loop statements, that is printed %d no part of P. No part of P meta is contained by the node which is located at the 200 location. So in 200 location, the node contains 20 at the data pad. So when we execute this, then it will display 20. So first the node display as 10, then second node display as 20, then next P equals to P nest. So now P is 200 and when we execute this statement, P nest means at the 200 nest part contain 300. So this value will store in the structure pointer variable P. So now P becomes 300. Okay. And when P becomes 300, again we will go for the while loop execution and we will check the condition. 300 is not equals to null. The condition is true or false? The condition is again true. As this condition is true, then we will execute the loop statement or the statement which are present within the loop, that printed %d P no. That means P now 300 and we will display the data part of the node which is located at 300 location, right? So in 300 location, the data part of the node contain 30. So now we will display 30. Okay. Then after displaying 30, then again we will go for the forward traversing. For that I can execute P equals to P nest. So now P is 300 and P equals to P nest means at 300 nest part it will contain null value which is stored in the variable P. So now P contain null. Okay. And again we will check the condition, that is null is not equals to null. So this condition is false. And when this condition is false, then we will exit from while loop and as well as from the else part of the loop. Okay. And when we exit from the else part of the if block, then we will end the function block because we already traversed all the nodes, those are present in the list. So this is the ending process of the user defined function, that is display. Okay. So this is how we can traverse a single linked list. Okay. So next we will see the algorithm implementation of this function. So the algorithm implementation for displaying the single linked list data. Okay. See, this is the void display start node stat. For that, you just write the name of the function display. Okay. Is contain the start pointer. Okay. Then step 1. In step 1, write start keyword is the indication of the start of the algorithm. Then in second step, we will set the start value to variable P. Okay. That means initially start contain null and after creating the list it will contain 100 and still P contain null value. Okay. And when we execute this for algorithm, we can write set P equals to start. Set P equals to start. Okay. Then comes to step 3. In step 3, we will check the condition, that is the list contain any node or not. So for that I can write if P equals to null. If this condition is true, it means the list is empty. There is no node present in the list. If this condition is true. So for that I will display a message, that is print equals to none. Then comes to else part. That means if it is not true, that means if P is not equals to null, that means P contains a node address, that is the starting node address of the list. So then I will go for the else part. Okay. In else part, I will execute a loop, or I can write repeat the step 7 and 8 until P not equals to null. Okay, you can see this is the condition. We will be execute these two statements until this condition is true is the condition, and we will execute step 7 and 8 until P not equals to null. In 7 and 8, we will be display the number part of the node, and we will assign the next address of the node to the pointer variable. So int inner part of the P. That means P contain the node address, and we will display the number part of the variable, the pointer variable P. Step 8. In step 8, we will set the next node address to the pointer variable P. So set P equals to P nest. Okay. Then end of the if statement. End if. Then next end of the algorithm. Stop. Okay. That means when this condition is false, that means the list contain at least one node, and we will be traverse that node. Then go for the else part. In else part, we will check is true or false. As we are assigning the start value to P, so P becomes 100. And when P becomes 100, this condition is true. As this condition is true, then we will print no part of the P, and we will assign the next node address to the variable P. When it will execute P of NO, then it will display the first node data part, that is 10. And when we set P equals to P nest, then P becomes 200. Okay. And again we will execute or repeat the statement, repeat the step 7 and 8 until P not equals to null. So now P is 200. So 200 not equals to null. This condition is again true. As this condition is again true, then we will execute this. That means we will display no part of P, and we will assign the next node address to the pointer variable P. And when we display the inner part of the P contain 200, and we will display the inner part, that means 20. Okay. And next statement, that is in step 8, we will assign the next node address to the variable P. That means now P becomes 300. Again we will, that means 300 not equals to null. Condition is true. As condition is true, then we will display again no part of the P, and we will assign the next node address to the variable P. So no part of the P means P contain 300, no part of P means that is 30, and we will assign next node address to the variable P. That is in the next part of 300 it contain null. Okay. Again we will go for the step 6. Repeat the step 7 and 8 until this is true. So now P is null. So null not equals to null. The condition is false, and we will exit from this to step 9, that is ending. Then now we stop the procedure. So this is the algorithm how we can display the nodes in single linked list, or how we can traverse a single linked list. This is the function implementation, and this is the algorithm implementation of to display the number of nodes in single list program. Thank you. Have a nice day.